that's a great segue into what I wanted to talk about AI. Great information about where the data is, how much is together, how much is not together, and why Canada can be or cannot be the big player. I think it can be the big player because there is lots of ways data can be manufactured, but many like adoption model can be wrong. So I'm not a domain expert, so I'm not going to say much about it. A little bit about myself. I have a small consultancy firm called API Garage. We do a bunch of API related work with HAL 7 and other stuff recently. I have 10 plus years of software consulting experience. I'm a technical mentor at Biomedical Zone, a collaboration between Ryerson University and St. Michael's Hospital, and recently jumped into AI with somewhat experience in it, and starting a community called Applied AI Toronto in downtown. We have a first meetup coming in 26 July, so all things there. If you have any questions regarding, please talk to me afterwards. About the company, here's a list of our clients. Not so great. Deloitte is the highlight one. Kai Innovation is another. Health, EMR, they use Oscar internally. But what I'm here to really talk about is how AI can change healthcare. And instead of focusing on use case, I'm going to talk about the implementation learnings that we have had in the past projects that we have worked on. The reason I don't want to focus too much on use cases for now is because it's just a Google search away. If you search for AI in healthcare, you're going to find tons and tons and tons of results, but very few are going to talk about what problems are having, what are the major, I wouldn't call fails, but unsuccessful projects out there that we can learn from. So that's what I want to focus on, and our company philosophy is around what can we do today to reach to the future in next 10 years. So we're going to discuss the next 3 steps that we can take today or in the coming week to reach towards the future. So that's what I'm going to try to focus on. So as David mentioned again, I'm going to refer to him because there was a lot of good content there. We generate a lot of data as humans. To be precise, 2,500 terabytes created on daily basis, and we double the amount that we have total every 2 years. So it's growing exponentially. Crazy amount of data is being generated every day. 90% of the data is unstructured. So when I say unstructured, think about it as videos, images, emails, text, blog, something that is not formatted enough so that there is not real information that you can draw out from directly. So that's where most of the data lies. So coming back to this one, even though we generate this much amount of data, we only use 0.5% of it. Means it's very small amount, and rest of the data is not being used for anything else. And here are the examples of where it can be like used very efficiently. So predictive analysis, sentiment analysis, recommendation engine in general, churn prevention, anomaly detection. Deep learning is just a small segment of it, and evolutionary strategies. So lots and lots of ways you can use the data to make sense out of it so that you can create smart systems. Now, coming back to this previous slide, what I want you to understand in this one is why data is important right now than before with the accuracy. So I want to step back like 5 years ago. So 5 years ago, or even 10 years ago, we have been using traditional algorithms, so linear models and things around it, where everything was coded manually by a software developer. Fast forwarding a couple of years, and then machine learning became, like it was always there, it just became more and more prominent, because what happened was, with no matter how much amount of your data you provide to traditional algorithm, at certain point, the gain with the big data is linear. No matter what you provide, the gain is very fractional. And that's when you need to improve on your algorithms. Even if you do like more smart algorithms, the fractional gain is to come. So that's when the machine learning came in, and that's where the neural nets started playing in a big role. If you have a smaller neural net, it's a technical way of saying, how would I say it? In layman's terms, it imitates like brain, how the brain functions and how the brain has neurons in it. So it's the same way. If you have a small brain, the amount of data you provide it's gonna grow exponentially, and until a point where it suddenly starts like going linear again. And with large brain neural net, what's gonna happen is you're gonna have like a more consistent feedback. So because of this big data wave, now neural nets are picking up again. Before, like neural has been out there for like in early 80s, but suddenly it's picking up again because we have more data that we can feed into, high computing power, Azure, IBM and others, and because of that, things are getting much faster. So instead of waiting for like 2 years, now things can be done in 2 minutes. So that is practical, and because of the use cases with the cell phones and everything, people have more and more reasons to interact with technology. So this is what I want you to understand. The key takeaway is because of the rise in amount of data, we are having rise in like machine learning algorithms. Here is just a small set of AI startups in US, which is this picture is like 3 years old, and I couldn't fit in the another picture on the slide. That's why I didn't. The number was like 4 times higher than that, so nothing would make sense out of it. But the idea is, with even this much amount of data, you still have a lot of companies trying to make sense out of it and making useful experiences. And these are the 5 major touch points of AI in healthcare at the moment. The biggest one is patient experience. So personalized healthcare. Doctors cannot give enough attention to each and every individual patient because of the time constraint. And with also data constraint as well. A doctor cannot process all the data available for the patient every single time to provide the right healthcare advice. In this particular case, with machine can churn millions of times more data than a human brain and then provide a better healthcare. So right now, it's not here to replace the doctors, but to give doctors, like work with doctors to provide a better advice for more personalized patient experience and healthcare. Drug discovery, there are 5 or 6 companies working on figuring out new drugs with all the permutation and combination available with the data right now, and coming up with new drugs. Nothing in the market yet, so that's the just matter of time. It's gonna soon happen. Imaging diagnostic, this is the most hot market in AI for healthcare, where you take an image and you try to identify if something is wrong with this or not. So you look at oncology, you take a picture, and then you should be able to figure out if there is a cancer or not. If you take a picture of a wound, and then you figure out how severe it is, and without the doctor, you might be able to get some first aid attention to it right away. So this is where, this is super happening place. If you send me an email, I can send you like a 12 to 15 of different startups working in this particular area. IBM is one of them. They have their own product working on this one as well. Next interesting is cost optimization. So in terms of cost optimization, it's more about how can we go and improve the current processes, and of course, like smart CDR and others like that is really important. Because of the standardization, you can now have smarter processes that does things very fast. And the last one is remote patient monitoring. It's a kind of an IoT, Internet of Things, and AI combined play, where you have smart sensors embedded as part of your body for specific organs that need monitoring, and based on certain scenarios, there can be alarm, warning, or even a treat. Like you can have an ice cream today because your diabetes level is pretty good. So there can be different experiences can be built around remote patient monitoring with IoT and AI play. So as promised, I'm gonna run through a couple of experiences. Okay, I'll be quick. So as I said, I wanna run through a couple of examples of failed, unsuccessful projects. The first one is, this is the most famous one. If you're working in AI, this is the one that you're gonna hear all over and over again. I was in fact debating whether to put it here or not because it's too common. But it's too important to understand. Like Microsoft created a Twitter bot that learns from people tweeting at that bot, and based on that it was creating its own identity. And soon, within 48 hours, they had to take it down because it became a racist bot and made all these comments around it. It was right. Trump won, but other things were pretty bad. So what can we learn from it, right? So what can we learn from it? So data is the key component to any AI. So make sure the data you're providing is filtered and you know the source of the data. Make sure that it's unbiased. Unbiased data is a myth at the moment, I understand that, but try to cover it as much as possible. Try to have unbiased data as much as possible. If you know it, go fix it. So that's the idea. The second one is test locally, but use the production data. So this is a software development problem. Whenever they talk about development, they manufacture the data. With this kind of example, especially with AI, you have to use production data, but use locally for training purposes, and then you will see all the problems that other people will see. So this is more when you go and implement 4 or 5 different weird systems, and then you realize that the manufactured data doesn't work. You have to have the real data working, otherwise things don't work out at all. And the last one is monitor the usage right after going live, and of course, have a kill switch. If something goes wrong with the AI, you have to have the kill switch. So there has to be a person, finger on the button saying, turn off. Not exactly, but metaphorically. The next example is kind of my favorite and kind of super frustrating. IBM and MD Anderson got together for some research on cancer. The project was budgeted roughly in between 10 to $15 million, if I'm not mistaken. And it went out of budget to $62 million. The project were nowhere to be found in practice. And right now, MD Anderson is looking for more and more bids or contractors to come and finish the project. So there are a couple of reasons, but I want to come down to what happened there and what can we learn. The first thing that we can learn is they forgot to involve IT department all combined. They just said, okay, we'll do the project, but we don't need IT in the beginning. So this is happened. IT people said, we were not involved at all. So have that involvement from day one. Kind of common sense, but you can skip it. Do not underestimate the data cleaning and integration work. Mind you, in any AI project, the most amount of time you spend, 60 to 70% in cleaning the data and making sure it's properly annotated and ready to be fed into an AI model. And the last one is, do not over-invest in the project itself. Try to, speed up. And try to have a technical prototype before going further. Again, a common sense with lean agile methodology, but many people don't think about it. So lean agile methodology, use 2-week idea where you can just make a technical validation project and then move on pretty fast. I'm going to skip over this example because they didn't do much bad other than they forgot to ask the users for, can we use your data or not? So make sure you do that. So this is a big one, but right now they are under investigation because of that. So as I promised, next 3 steps. Much content, but I'll squeeze it down to 2 minutes. The first one is use cases. Statistically, 50 to 52% people don't know what AI will be doing for their company. So half of them, if you flip a coin, half of them know, half of them don't know. And so build use cases. Without use cases, there is no clear ROI. There is no money to be made or anything around it. So that's first. Clean up and start annotating your data. So do that probably next week. Talk to your data scientist or CIO or whoever there is. Go and figure out how you can start cleaning up your data today so that you can start using AI next year. So it's going to take you 12 months no matter what you do. So sooner you start doing it, the better it is. And start experimenting. People are going to fail. We are all going to fail. Like my dad always says, start failing soon. This is part of that. But make sure that you keep it private before going to public, unlike other companies. Make it private and make it in a way that it doesn't harm the current system. Otherwise, this is more details into it. The last thing I want to really focus on is something we do. I don't want to make it super biased, but this is what we really see value in AI design sprint while building use cases. It's a 5-day process taken up from the product design sprint by Google Ventures, where First day is focused on getting the business value, what ideas you want to work on, and day 2 and 3 and 4 are focused on taking out the data and seeing, can you build a technical validation out of it? And the last one is building a big level architecture and a small user experience prototype so you can get some validation. So this 5-day process, it's an open source process. You guys can go and check it. It's simple as aidesignsprint.com. And this can save you millions of dollars. Other than that, you will get this slide later on. You'll be good. Thank you.